Hello everyone, this is Jake from State Farm. Tom from TutorBros. Today we're going to learn how to simplify radical expressions, specifically square root expressions. Now remember that a single radical can be written as the product of two or more radicals by breaking down the radicand, which is the expression under the radical, into some combination of its factors. So for instance, I could rewrite the square root of 10 as the product of the square root of 5 times the square root of 2. Or I could rewrite the square root of 33 as the product of square root of 11 times the square root of 3. So you get the idea. Now, when asked to simplify a radical expression, what we want to do is find the highest perfect square factor of the radicand and break the expression down accordingly. So let's do a couple of these together and see how that works. Let's take a look at number 1 first. We have the square root of 24. So we think about all the factors of 24 and determine what the highest perfect square factor would be. I'm going through all of them in my head. I think that the highest perfect square factor would be 4. So one of the expressions that we're going to break this down with is going to be square root of 4. And then how many times does 4 go into 24? Well, that would be 6. So the square root of 4 times the square root of 6 is going to be equivalent to our original expression. Now the reason that we're looking for the highest perfect square factor is so that we can break at least part of the original expression down into just an integer. So if we take the square root of 4, that's just going to give us 2. And then we can still multiply that by the square root of 6, which we can't break down any further because it doesn't have any perfect square factors other than 1. So our final answer here would simply be 2 times the square root of 6, and that is equivalent to the square root of 24. All right, let's try another one. We'll do the square root of 50 here. So what is the highest perfect square factor of 50? I'm running through them in my head again, and I think the highest one is going to be 25. So we can write the square root of 25. And then we ask how many times 25 goes into our original radicand, which is 50. That would be 2 times. So the square root of 25 times the square root of 2. And then we can break that down by taking the square root of 25, which is simply 5, and then multiplying it by the remaining radical expression, radical 2. So the square root of 50 can be rewritten as 5 times radical 2. Alrighty, now we're going to do one more together, and this time we're going to include a couple of variables in our radical expression. So take a look at number 3. So the radicand is 75 a to the 4th b to the 5th, so we're taking the square root of that. Now the process is exactly the same. We're still looking for the highest perfect square factor, but it can become a little bit more complicated with the variables. But let's just start with the number. We'll start with the 75. What is the largest perfect square factor of 75? I think it'll be the same as in number 2. It's going to be 25. So I'll write square root of 25. But we're not quite done finding out what the largest perfect square factor is, because we also have to take a look at the variables. Now a to the 4th is itself a perfect square, because anytime you have a variable expression with an exponent, if the exponent is even, then you can take the square root of that by simply dividing the exponent by 2. So a to the 4th is going to be part of our perfect square factor also. Now how about the b to the 5th? So the exponent here is odd, so we wouldn't be able to take the square root of that, but we could take the square root of b to the 4th, which is a factor of b to the 5th. So we can include b to the 4th in our perfect square factor as well. Right? And then we have to find another radical expression by asking ourselves, okay, 25 a to the 4th, b to the 4th. What do we multiply by that to get to our original radicand of 75 a to the 4th, b to the 5th? Okay, well 25 goes into 75 how many times? Well, that would be 3 times. And then a to the fourth, to get to a to the fourth, we just multiply by 1 so we don't have to express the a again. And then b to the fourth to b to the fifth. How do we get from the first to the second? Well, we just multiply by b. So b to the fourth times b would be b to the fifth. So we have to add that last b here in the second radical expression. Okay? And then the last step again would be to find the square root of the perfect square. So that would be 25 a to the fourth b to the fourth. So the square root of 25, again, is 5. Square root of a to the fourth, remember we take the exponent and divide by 2 to find the square root, so that would be a squared. And then we do the same thing with b to the fourth, divide the exponent by 2 to get b squared. And then we're still multiplying that by the second radical expression, which would be 3b. So the square root of 75a to the fourth b to the fifth is equivalent to 5a squared b squared times the square root of 3b. Just a reminder that in this video, we only looked at square root expressions. The process for simplifying other kinds of radical expressions is almost the same, but with one very important distinction, and we do cover that in another video, so please be sure to check that out.